Herkese merhaba. Bugün
Hello and welcome. Today I will focus on neurobiological studies most up-to-date about dreams. First and foremost, in the context about dreaming, there are some terms we need to talk about. We can call dreaming as sleep mentation or dream experience or mental activity during sleeping period. Whatever it is called, dreaming is a state of consciousness occurring in a physiological condition, according to Cipollone and colleagues in their most recent publication in 2017. Now, there is no true consensus about the definition of dreaming. There are some important names, such as Alan Hobson, who says dreaming is as psychotic a state as we experience while being awake. And Alan Hobson is the one who created the activation synthesis hypothesis. Hobson says dreaming results from REM sleep physiology. Recent theories suggest dreams fulfill an adaptive function associated to emotion regulation and memory consolidation. But we know that dreaming is very broad and can range from thoughts and isolated images to story-like experiences that might be recalled upon awakening. As you very well know, sleep consists of several cycles of REM and non-REM, and they range about 90 to 100 minutes. In early 1950s, REM sleep was discovered. It is characterized with global high frequency and low amplitude EEG signals. In the early days, dream physiology was just associated with REM sleep, because people are most likely to report their dreams after waking up from this phase. But we know very well that REM sleep and dreaming need to be separated. Lesions in the forebrain can leave REM sleep normally or intact, while brainstem lesions prevent REM sleep from occurring, while people also report dreams after awakening. As you know, today, dreams can be detected in REM and non-REM stages of sleeping. I will share a very up-to-date study towards the end of my study. I will talk about non-REM sleep. It is now divided into 3 different cycles, N1, N2, and N3. N3 sleep is known as deep or slow wave sleep. In opposition to REM, non-REM sleep is characterized by global low frequency and high amplitude EEG signal pattern. Some researches indicate that non-REM dreams are recalls of REM dreams during awakening period. We today know that dream reports of non-REM sleep are not just a recall of dreams that occur during REM sleep phase, or people even report dreams after waking from short naps in the afternoons. They can also report dreams. Some researches suggest that non-REM dreams are related to hidden REM activation not observed in polysomnography. But as I will mention towards the end of my speech, that is not the case, and this view is now in the annals of history. REM, non-REM, and wakefulness are not really different from each other, because sleep is not comprised of homogeneous mental experience. And as I have mentioned, dreaming is a very broad spectrum which ranges from thought-like content, usually seen in the first stage or early stages of non-REM sleep, to very vivid dreams that are more typical of REM sleep. Most experiences during sleep are rather similar to those during wakefulness. How? We feel all the senses. We can see very colorful dreams. We feel pain. And it's very realistic within the dream. And more importantly, the structural organization of the dream is usually similar to that of wakefulness consciousness, in that dreams involve experience of a world within which we are the center of it. Ramonzio says that dreaming is nothing but consciousness, or to be more precise, the macro level of consciousness at its barest, functioning or operating on its own. Focusing on up-to-date researches, let's focus on active regions, REM and non-REM sleep. EEG signal patterns during REM sleep is similar to wakefulness, and also PET studies have shown that global brain metabolism tends to be rather similar too. There are some active regions in REM sleep. For example, amygdala, anterior cingulate cortex, hippocampal formation, forming the limbic and paralimbic structures, basal forebrain, thalamus, and pontine tegmentum are associated with emotional processing, and researchers have said that emotional aspects of REM sleep dreaming are related to these regions. And I think it has been proven. At the same time, studies also suggest that temporal visual cortex correlated with very vivid visual imagery, primary motor, premotor cortex, cerebellum, and basal ganglia reveal high activation during REM sleep. Additionally, medial prefrontal cortex, medial temporal lobe, posterior cingulate cortex, are related to self-referential processing, are active in REM sleep when compared to wakefulness. These three areas, medial prefrontal cortex, medial temporal lobe, and posterior cingulate cortex, are important because there's an overlap between the default mode network and areas become increasingly active during this REM sleep. And default mode network, or DMN, is the network of brain regions that are active when an individual is awake and not engaged in a task. It is also associated with self-referential functioning and processing of dreams as well. And this network plays a key role in dreaming and mind wandering. I'd like to show you a picture. You see a slow wave, and then on top and in the bottom you see wakefulness. You see that slow wave. During slow wave they are not very active. In wakefulness they are slightly active, but in REM sleep they are very active. Now, there's also deactivation of some region during REM sleep, like dorsolateral prefrontal cortex, orbitofrontal cortex, posterior cingulate gyrus, precuneus, and inferior parietal cortex. And they are inactive due to cognitive control, metacognition, ego functions, related to the absence of these. The red areas are active and blue areas are inactive in REM sleep. Let's focus on non-REM studies. After being awake of non-REM sleep, 70% of people report dream experiences. Sometimes REM sleep awakening does not mean that those people have to report dream experience. So the paradoxical occurrence is here, and it's a very new novel trial here in this pattern. This major study is revealing decrease in low frequency activity in posterior cortical regions. Serial awakenings of subjects recorded throughout the night is listed, and then a high density EEG recording is made, and posterior hot zone is detected, and there's a local decrease in low frequency EEG activity during both non-REM and REM sleep in this hot zone. However, a local increase in low frequency activity is related to the absence of dreaming experience. And this area is called posterior hot zone or high activity zone. Moving on. It is possible to predict whether a person will report having dreamt or not at the non-REM sleep by real-time EEG monitoring. And this is the result of the previous slide. We can take a look at the specific contents of dreams in REM sleep. In this trial, they took a look, and we see that high-frequency activity is correlated with thinking dimensions in frontal brain regions and also perception of dimension. So they see that high-frequency activity is also related to the content of the dream and also correlated with parietal and occipital temporal areas. And these findings show us that anterior cortical regions mediate these thought-like experiences. Also, high activity in right superior temporal sulcus is also associated with sense of movement in the dreams, and high activity is detected here. Looking at dreams containing speech were associated with left posterior temporal region corresponding to Wernicke's area. I will present this presentation and then move on to the summary. I will give a specific definition of these dreams. Dream can be described as a special state of consciousness comprising of complex internal activities of specific brain regions leading to emotional, sensory and cognitive experiences during sleep. Thank you.